All right, ladies and gentlemen, let's get started with the solutions to Builder 2. In question 1, we are asked to identify the slope, which we're calling m, and the y-intercept, which we're calling b. Okay? So this equation is written in the form y equals mx plus b. And so it should be possible to actually read the slope m directly off of the equation. So the slope is 5. Okay? The y-intercept is 2. Okay? But is it 0, 2 or is it 2, 0? 0, 2. Very good. Very good work. Raise your hand if you got that one right. That's great. That's great. Okay, again, this is already in the form y equals mx plus b. Okay, b can be negative. In this case, it's negative. M is negative. What's m? Negative 3 over 5. Very good. And what's b? 0, negative 9. Good job. Now on number 3, we talked about this yesterday. This graph, if I were to graph it, it would look something like this. I'm just drawing a quick graph here. I'm not going for accuracy. I'm just going for the concept. You would have a point plotted on the y-axis at 9, and that's your y-intercept, 0, 9. And then the line itself would be a perfectly horizontal flat line. Okay? I think we were talking yesterday that if you were walking on this line, you would not be walking uphill or downhill. You would just be walking flat. So the slope is 0, and the y-intercept is 0, 9. These problems always look like this. Y equals a number, guaranteed to be on star. Okay? Guaranteed to be on star. Whatever the number that y equals, that's the y-intercept. The slope, if it's y equals a number and there's no x involved, the slope is 0. Okay? Moving on to number 4. So when we were looking at this yesterday, we went ahead and put that 1 in between the negative and the x, and the original problem read negative x minus 1. And so now this is in the form y equals mx plus b. What's m? Negative 1. Very good. Can I ask a further question? What would be the rise and the run here? What do you think? Yes. Perfect. Negative 1 over 1. So when the rise is negative, we call it like fall. Okay? If you wanted to see what this looked like graphed, it's very easy to sketch a quick graph of this. Sometimes these little tiny pictures help us. We have a y-intercept at negative 1. Okay? And then it's just down 1 over 1 to the right. Okay? So your next point is there. And your line would look something like this. Okay? Negative x minus 1. And we said, okay, so what's the y-intercept? Very good. I think I heard Anivia there. Very good. Now, over here on number 5, it actually is in y equals mx plus b form. But the m is weird. What is m? What is it? Lovely. I heard everyone in chorus say negative 1 over 4. So what is the rise and what is the run? Who said that? Leilani? 100% correct. What? Now, 12 over 3. That's a trick because what is that number really? What's 12 divided by 3? So what's the y-intercept here? Can you give it to me in coordinate notation? Very nice job. I am really proud of all of you. I really am. I'm thinking back to 7, 8 weeks ago. We've come a long way. Now, Dee Dee, this is another one of those that's going to be on the STAR test. X equals 5. If I were to plot x equals 5, here's what it would look like, okay? You would have your normal x and y here. We would label this y and label this x. And then you would have 1, 2, 3, 4, 5. And you would have a perfectly vertical line right here. And this equation of this red line here is x equals 5. The slope is undefined. Okay? It's parallel to the y-axis, so it never crosses the y-axis. Never. Okay? So the y-int is also undefined. What's the x-intercept? In coordinate notation? 5, 0. So these are the 3 questions you'll be asked about. They'll give you an equation. Okay, they'll say x equals 6. Or they'll ask you a question. They'll say, please write the equation of a line with an undefined slope that passes through x equals 6. Or that passes through 6, 0. And you have to know, okay, they want me to write x equals 6. So in both the m and the b are undefined. Please watch out for these 2 types of problems, numbers 3 and 6. These are your alligators that are going to come up out of the water and get you, okay? These are easy money. If you know the rules, they're going to be on the STAR test. Okay, now this next thing, I kind of need to turn on the lights because I want to try to mix in a little bit of me being on camera here, since that's what, that's the intent here. How are you doing so far on this? Pretty good? If we get done with this early, I have all of the winning plays from last night to show you. Yeah, from volleyball. Just a second. Okay. Actually think I can. I'm going to be able to erase more of that. Okay, on number 7, you're given y plus 5 equals 3, open parentheses, x plus 1, close parentheses. Now, the way I put this on this paper, you're going to have to write pretty small. But first, we need to distribute this 3, right? Anivia, right? Got to distribute the 3. Let's make sure we're putting our vertical line here. So we rewrite the left side, y plus 5 equals 3 times x is 3x. 3 times 1 is plus 3. Now we subtract 5 from both sides. The 5's cancel out because they're additive inverses and they sum to 0. And y equals, bring down this 3x, and then perform subtraction. 5 from 3 is negative 2. Well, this is in the form y equals mx plus b. What's m? So m equals 3, but can we write it as rise over run? 3 over 1. Okay? So you're going to rise up 3, and you're going to run to the right 1. What is the y-intercept in coordinate notation? Yeah, this is your equation, okay? 0, comma, negative 2. Great job. So to graph this, you already have a graph. We start at 0, comma, negative 2. So we would need to count down 2 spaces. 1, 2, negative 2. We'll put a dot here. This is 0, comma, negative 2. This is our y-intercept. And then we use the rise over the run to go up 3 over 1. Okay, so we go up 1, up 2, up 3 over 1. This point should be 1, comma, 1. Is that what you did? Okay, then you connect the dots like this, and you draw a line. Not a line segment. You have to put the arrowheads on the end. You draw a line. Is that more or less what your graph looks like? If not, please make sure you get that corrected. More importantly, make sure that you understand why it looks this way. Can I erase? Okay. Let me see if I can. Now, every time I try to get away with reusing the graph, it just looks confusing. All righty. Number 8. On number 8, you were given y minus 3 equals 2, open parentheses, x minus 4, close parentheses. What's my first step? Distributive property. And then we got to draw our line. Okay. So do we touch the thing on the left? No, we just bring these two homies down here. Now, Dee, what's 2 times x? Perfect. Oh, I'm sorry. And Diego, what's 2 times negative 4? He's sitting right there. Is it positive or negative 8? Yeah, we're multiplying 2 times negative 4. So negative 8. Okay, now, Joey, what's the last step? Right? This is going to cancel, right? What's it going to be? Negative 5. Okay, just so you know where this is heading. I'll fix that in a second. Okay, so we add 3 to both sides. Cancel. Y equals 2x minus 5. Okay. Now we're going to graph it. Well, before we graph it, we're going to identify. So this is indeed written in y equals mx plus b form. What is the m, the slope? 2. And what is the y-intercept? Inclination. 0, negative 5. And this slope, can we write this as rise over run? 2 over 1. Very good. Okay? So now let's draw it. And I made your graph, I kind of set it up so you could graph it more easily. Since we're going to be in the negative, this y, x, and so we go down 5, 1, 2, 3, 4, 5, and we'll see what we need here. Okay? So we go down 1, 2, 3, 4, 5, and put a dot here at 0, negative 5. That point is my y-intercept. Then I use my slope, up 2 over 1, up 2 over 1, up 2 over 1, to go up 2 over 1. You could do it again if you wanted. Up 2 over 1. You see what you're doing? Up 2 over 1. Up 2 over 1. You get it? My last one didn't get lined up right, but they should all line up. You only have to do that one time, but sometimes it helps to do it a few times. There's your line. This is the equation y equals 2x minus 5. Okay? Very, very good. Now, the next problem is y equals 2. Can someone verbally describe for me what that's going to look like? That would be x equals 2. Say it. Wonderful. Perfect. Say it again. Horizontal line. Horizontal line passing through 2 on the y-axis, right? Y equals 2. Horizontal line passing through 2 on the y-axis. This is when that inception thing starts happening, right? Folks at home can't see. I wrote on the smart board, which has got a projection of the camera. So it's like an image within an image within an image. Have you all seen Inception? Where they dream? It's a dream within a dream within a dream. Leonardo DiCaprio's in it, the guy from Titanic. And Django. Everybody seen that movie? Django Unchained? Yeah. He was the bad guy. He was the one that hit his hand on the table and cut his hand. Did you know he really did that by accident? That was he was just like way caught up in the moment. Yeah. Yes. Okay, so this is number 9. There's no work to do. You're just given y equals 2. Okay? So the key thing to remember is that the slope is 0 and that the y-int is going to be at 0, 2. Okay? So let's just say, for example, that this is our graph. Here is 2. And so we're going to have a perfectly horizontal line. Did you guys get this one right? Makes me happy, okay? We had a gentleman say, what about a vertical line passing through 2? Okay, let me draw that for you just so you can see it. This is not part of the problem, but let's say that you were asked to graph this equation, x equals 2. What you do is you'd come over 2 places, okay? Remember, the slope would be undefined. And it would be passing through, be a perfectly vertical line passing through 2 on the x-axis, okay? So the purple line here is x equals 2, and the red line is y equals 2. Please, actually, I'm really glad you brought that one up because it's easy to get the rules confused. So make sure, these are our 2 extreme cases in algebra. Here's the other extreme case that I didn't show. How about this one? Ready? Y equals x. Yes, so it's going to have a y-intercept. It has a slope of 1 and a y-intercept of 0, 0. Okay? So here's your y-intercept. Now check this out. Up 1 over 1. Up 1 over 1. All right? Y equals x is an interesting property. It puts itself at a 45-degree angle. Look at this. 10, 20, 30, 40, 45. You'll learn more about this in geometry. But look at that. Look how those dots line up. Isn't that crazy? So here's y equals x. You cannot hardly see that. Let me try blue. Y equals x. Slope of 1. Y-int at the origin. Those are your 3 weird ones, okay? So you got y equals 2, x equals 2, Y equals X. Yes. Yep. Yeah. And Y equals negative X, guess what it's going to look like? It's going to look like this. Y equals negative X is going to look like that, okay? Just going to be the same thing as Y equals X, but going downhill. Great. I think that was productive. So we got done with number 9. Number 10 looks really hard. Did anyone solve it, by the way? Joey, did you solve number 10? Ooh, okay. Let's take a look at that. So here's number 10. 6, open parentheses, x plus 4, close parentheses, over 2 plus 2x equals 5x plus 12. We're asked to solve for x. What's the first thing you would do? Distribute. Okay. Did you mean distribute up here? Okay. So 6 times x is 6x. What's 6 times 4? 24. I always remember 6 times 4 is Christmas Eve. Right? Okay. Over 2. Plus 2x equals 5x plus 12. Joey, what'd you do next? Divided by 2 here. Can we do that by canceling like this? Do y'all understand that you have to divide both terms by 2? Because that's a sticking point for a lot of people. Now, what is 6 divided by 2? What is Christmas Eve divided by 2? 12. Okay? 24 divided by 2 is 12. So we're going to rewrite this as 3x plus 12 plus 2x equals 5x plus 12. Now, Tabitha, what shall we do next? Okay. Joey, what did you do next? On the left side, you combine like terms. What he's saying he did was he noticed that 3x and 2x were common. So he did one of these deals. What's 3x plus 2x? 5x plus 12 equals 5x plus 12. At this moment in time, your brain should start going, huh, it's weird. Now, what did you do, Joey? He subtracted 12 from both sides. And we have 5x equals, look at this, they cancel over here as well, 5x. Now what did you do? Divide both sides by 5. Okay. Okay, those 5s all cancel out. Now I have x equals x. What'd you do now? Okay, so let's take a look here. So we have 1x equals 1x. Take the logical next step and subtract 1x from both sides. What's 1x minus 1x? 0 equals 0. Is this true by the identity property of equality? So you write down true. Now, what do we say about these weird situations? When it's true and it's a number equal to the same number, what is the solution set? What do we talk about? One of them was no solution. That's not this situation. That's when it's false. When it's true, what is it? It's every infinitely many solutions. So we can write all real numbers. We also write negative infinity less than or equal to x less than or equal to positive infinity. Or we write infinite solutions. Okay? Basically, all of this. Okay? These are three different ways of saying the same thing. How did that strike you? It's difficult to get here because you start doubting your own math. You don't think the teacher's going to do this, but just be aware that I've seen it on the STAR test enough times that I want to make sure you get exposed to those weird problems. Okay, number 11. Did anyone get the answer on number 11? You're being asked to simplify, not solve. Negative 3 over 10 plus 0.42. Okay, now the first step in this problem is to go over here into side work and convert 0.42 into a fraction as 42 over 100. And then you can actually cancel that down to be 21 over 50 by just dividing the top and the bottom by 2. So let's go back and write this again. Now we have negative 3 over 10 plus 21 over 50. Now we can't combine because they're not common. So what do I need to do? The lowest common denominator is 50. What do I have to multiply by 10 to make 10 be a 50? Right, so remember, you can only multiply a fraction by 1. So I have to multiply by 5 over 5. Okay? What's 5 times negative 3? Negative 15. Very good job, guys. Appreciate you keeping up. And what's 5 times 10? 50. So now I can add because I've got common denominators. Now, whenever you see negative 15 plus 21, you should think, okay, subtract 21 minus 15. Okay, it's 6. So my answer at this point is 6 over 50. Now, can that be reduced? Cancel, cancel. 3 over 25. Okay? Excellent. Who got that right? Nice. Can I erase? We're almost done. Stay with it. This next one's really easy. I think probably most people got it. Prime factor 42. Remember, your primes are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31. We'll stop there. 1 is not prime. So prime factor 42 means make the tree. Is this even or odd? So what's the smallest even prime number? 2, and then the cofactor is 21. But 21's not on this list, so I've got to keep breaking it down. Thank you so much. And so we circle the primes like they're fruit of the tree. And we just write that 42, you could have written 2 times 3 times 7 equals 42, or you could have written 42 equals 2 times 3 times 7. Okay, so here's what Shannon did. He did 42 as 6 times 7, and then he broke this down to 3 times 2. Did he get the same answer? Yes. However, when prime factoring gets bigger, when the number is bigger and the tree gets bigger, this becomes a huge mess. You want to prime factor by starting with the lowest prime. So it could be all 2s, and you'll see when we get bigger trees, you'll need a ton of space, and the math will get extremely disorganized if you do this. But if you're in a rut, if you're stuck, this is fine because you still got the same answer. It's not wrong, okay? I'm just asking you for stylistic reasons to do it this way. I'm looking ahead, and I know where it's going to end up taking you, so. Hang on just a second. I know the bell's about to ring. This one's important. Let's do number 13. Simplify x squared times x to the 5th over x. Okay? Hang on. Just hang on 1 second. It will only take less than 10 seconds, okay? You add them, and so it's x to the 7th over x to the 1st. Okay? And then you subtract 7 minus 1, and you get x to the 6th. Great job. Keep it, because tonight you have homework. Hey, listen, you need to hear this. Listen. You have this test 4 review, and you have Builder 3. Test 4 review and Builder 3. If you hang out, I'm going to go ahead and finish this. I'll give you a note. Hang on, I'm still recording here, okay? Can you pull that door closed real quick? Okay. So, number 14. It says write an equation for a vertical line passing through 5